Hello, scholars. We are on week 6, and this week our module is exploring equivalent expressions. I'll remind you that our expressions are math phrases that use symbols, numbers, variables, but they don't have an equal sign. But our job specifically this week is to look into whether or not they are equivalent. And so our learning objectives state that we are going to identify when two expressions are equivalent, and then we're going to use mathematical operations to generate equivalent expressions. So we'll write equivalent expressions. So we'll figure out when they are, when they're not, and then how to create them or write them. So our definition of equivalent expressions is that two expressions are equivalent if they have the same value no matter what the value of the variables are in them. But I'm going to give you like the key to 6th grade equivalent expressions. And as we're going to revisit that distributive property. And my first example is a really good reminder of that. So let me get my pen ready. And when we're looking at my first sticky note here, it says, are 4n plus 14 and 2 times 2n plus 7 equivalent expressions? When I see that I have 2 as a factor in front of these parentheses containing 2 terms, that's where my brain connects that I can distribute that 2 as a factor to both terms inside the parentheses. And that's my distributive property, when that 2 gets to act as a factor to all of those terms inside the parentheses. And I'll remind you what that looks like. And I like to use this on the whiteboard in the classroom, so I'll show you. That means that 2 is a factor, so 2 gets multiplied by 2n. And it also gets multiplied by 7. So I'll do 2 times 2n first. And I know that 2 times 2 is 4. So now I have 4n. So instead of those 2 n's inside the parentheses, I get that twice. So 2 times 2 is 4, but it's 4n since 2 is my coefficient. And I also get to utilize 2 as a factor when it comes to that other term, 7. 2 times 7 is 14. And I see I'm adding that. So plus 14. And so scholars, when I use that distributive property, because we're revisiting that, that's a standard from last year, I see that 4n plus 14 is the same as 4n plus 14. So those are, in fact, equivalent. So using the distributive property helps me identify when they are equivalent. That's one way. So another strategy that we'll look at with my other sticky note actually helps me identify when they're equivalent and then also write or generate an equivalent expression. So both of these strategies kind of help me with both objectives. I'm asked to write an expression that is equivalent to n plus p plus n plus 2p plus n. And so we'll use the terminology. We're going to combine like terms, which is really helpful when it comes to simplifying an expression or just writing it in a different way. So much like on the left side of my screen, instead of writing 4n as 2 times 2n, I wanted to show all those n's together. So that's actually what I'll do first, since I see I have n repeated a couple of times in this expression. So I have 1n, I have 2n's, I have 3n's, I have 4n's. So I can rewrite that as 4n. And now every single part that I'm crossing off in this expression has been accounted for. 4n's and 4n's. I just wrote it instead of breaking those n's apart as addends, I chose to write it as 4 times n, so factor times a factor times a variable. And then scholars, I see I have the variable p, and then I have 2 more p's. So altogether I have a p and then 2 more p's. So I can write it again, I'm adding as 3p. So I can kind of check off what I've done here. P plus 2p. So n plus p plus 2p plus n is actually the same as 4n plus 3p. And scholars, those are 2 strategies I can use to figure out if they're equivalent and then also generate equivalent expressions. So I can use a distributive property, I can combine like terms, and both of those things help me, they support me with these objectives this week. And for dinner tonight, I'm having macaroni and cheese. So definitely make sure you remember to type in macaroni and cheese.